Welcome, everyone, to today's Explainer lecture. We are jumping right into things today, focusing entirely on section 19.2 of your text, which covers conceptual design. This is an absolutely crucial first step in your software engineering program. Long before we start writing actual code or even jotting down formal technical requirements, we have to establish a clear system vision. It is literally the foundation for everything that follows.
So here's our roadmap for this masterclass. We'll quickly run through an intro to conceptual design, look at ConOps versus modern system vision, break down the 4 conceptual activities, structure the vision document, explore the power of stories, and wrap up with a summary and exam focus.
All right, let's kick things off with Section 1, Introduction to Conceptual Design.
To put it simply, conceptual design is the very first systems engineering activity you'll tackle. You take an initial spark of an idea, thoroughly investigate it, actively explore feasible options, and then develop a cohesive overall vision. Think of it like this. Someone suggests a system, and your job is to figure out, first of all, is this actually viable? And second, what would it realistically look like in the real world? All of this has to happen before a single line of code is written. But here is the real kicker, and it's a trap so many engineers fall into. This vision absolutely cannot be highly technical. It must be completely understandable to non-experts. We're talking about the politicians, the CEOs, the funding managers, and the everyday users. If your initial design document is just overflowing with dense engineering jargon, you are going to immediately lose the exact people who need to approve your budget. Moving right along to Section 2, ConOps and System Vision. Historically, we established this system vision using something called a ConOps, or Concept of Operations document. It originated in military systems, but the problem is, like a lot of heavy government standards, these documents became incredibly bloated and inflexible. They turned into these massive, unreadable manuals that function better as doorstops than actual guides. That's exactly why modern systems engineering pushes for a much more agile approach. We now use a system vision document. It's significantly shorter, highly flexible, and its main job is to tell a really compelling story about why the system is actually being built. Okay, Section 3, the 4 conceptual activities. I want you to pay close attention here as this is a very common exam topic. If you look at the flowchart from the text, the most important takeaway isn't just the boxes themselves, but how they overlap. Conceptual design isn't some rigid step-by-step waterfall process where you finish one task and never look back. It's iterative. You'll often be tackling several of these activities concurrently, constantly tweaking and refining your ideas as new information comes in. And it is always a team effort, bringing together people from completely different backgrounds.
Let's formally break down the 4 specific steps in that flowchart so you can get your notes in order. We have concept formulation, problem understanding, system proposal development, and system structure development. Let's walk through exactly what each of these means.
We start with concept formulation. This is all about refining an initial, often vague, statement of needs to figure out what type of system actually solves the stakeholder's problem. Say a university comes to you asking for a basic intranet because their old one is clunky. Well, through formulation, we might recognize that what they really need isn't just an intranet, but a highly flexible digital learning environment. Formulation takes that initial seed and hones it into a practical, modern reality. Which leads us directly into problem understanding. And guys, a huge mistake junior engineers make is forcefully pushing their favorite technical solutions onto users. But true problem understanding means actually talking to stakeholders, discovering their real barriers, and keeping an open mind about their everyday behavior. Always remember the golden rule here. It is their problem, not yours. If their daily workflow doesn't match your grand technical vision, you have to change your vision, not demand they change how they work. Next up is system proposal development. This is where the design team brainstorms various alternative systems. But we don't just daydream, we actually test these ideas. You have to run a feasibility study. Basically, it's a quick, focused reality check to see if your proposed system can genuinely be built on time and on budget using current technology. And the 4th activity is system structure development, where you define a high-level architecture. Instead of just buying one massive, inflexible block of software, you might design a layered service architecture. This is huge because it allows you to procure or build different parts of the system independently. You absolutely want to minimize the risk of creating a monolithic system where everything is so tightly tangled that changing one tiny feature breaks the whole shebang. Let's do a really quick recap of those 4 pillars before we move on. Formulation, understanding, proposal, and structure.
You refine the initial idea, you empathize with the actual human problem, you test feasible alternatives, and you outline a smart, high-level architecture. Together, those 4 overlapping activities build a rock-solid system vision.
Right, let's jump to Section 4, Structuring the Vision Document. Because the system vision document is read by completely different groups of people, it needs a dual structure. On one hand, you have the senior decision-makers holding the purse strings. They need a short, non-technical summary focused purely on business benefits. On the other hand, you have your requirements engineers and procurement teams who desperately need the highly technical constraints and architectural details to actually get to work. So you split it into 2 parts. Part 1 is that punchy, non-technical summary for the managers. Part 2 houses the heavy technical appendices for the engineers. Memorize the structure, because it's exactly how we balance selling the vision for funding while still providing the rigorous constraints needed to build the thing. Which brings us to Section 5, the power of stories. Remember how we said that manager summary needs to be non-technical? The absolute best way to do that is by telling a story. Instead of listing dry features like cross-platform synchronization, you write a narrative. You describe Jill, an art student who starts sketching on her phone on the bus, picks up right where she left off on her tablet at home, and submits the project from a school computer the next day, all while her teacher seamlessly reviews it. User stories strip away the tech jargon and allow non-experts to literally see the real-world value of the system you're proposing.
And that brings us to Section 6, Lecture Summary and Exam Focus.
Let's quickly distill everything we've covered today. Conceptual design is that critical first step to establish a non-technical vision. We know we're ditching the old bloated ConOps in favor of agile system vision documents. We walked through those 4 core activities: formulation, understanding, proposal, and structure. And we saw why the vision document itself must be split into a manager's summary and technical engineering appendices.
Now, listen up, because you'll definitely want to highlight this for your exams. You must be able to list those 4 overlapping activities from memory. Furthermore, you need to be able to articulate exactly why user stories are the most effective way to communicate with non-technical stakeholders in your system vision document. If an exam question asks how to pitch a complex system to a CEO, your answer should immediately revolve around crafting relatable user stories.
So what happens after this vision is approved? Well, that output acts as the direct bridge to our next topics. The procurement team takes over to create tender documents so suppliers can bid on the work, and the engineers start mapping out the nitty-gritty system requirements. Everything launches from the conceptual design phase. I'll leave you with this final thought as you continue your software engineering program. If the golden rule really is, it's their problem, not yours, how are you going to ensure your grand technical visions never lose sight of the actual, everyday people using them? It is so incredibly easy to get wrapped up in brilliant architecture and totally forget the human being on the other side of the screen. Keep that empathy front and center. All right? Thank you so much for joining me for this explainer lecture, and I will see you all in the next one.